For Netherlands Railways, the prospects are good. Passenger numbers are rising and the company's social status is improving. NS is playing an ever more important role when it comes to the point of increasing access to Dutch destinations and improving livability. With Rail 21, its plan aimed at the future, NS hopes to literally lay tracks into the next century. Amongst other things, the plan involves doubling the number of tracks on many routes, going from 2 to 3 train units, and providing greater comfort for passengers. One of the first and biggest projects in this connection is the extending of the Schiphol line. In implementing these expansion plans, NS will be keeping exactly to the so-called Schiphol 2000 master plan. As far as Schiphol is concerned, NS must start construction work without further delay because later there will be no time left. Our national airport does not want to merely maintain its international position, it wants to improve it. Within the next decade, Schiphol will gain the capacity for 34 million passengers per annum. At present, 16 million pass through the airport each year. As of 1992, transatlantic and EEC passengers will be channeled into separate flows. The latter category will be able to move within the EEC free of custom checks. With all its planned expansion projects, Schiphol hopes that by the year 2000 it will still be one of the top 5 biggest airports in Europe and, of course, equipped with the most modern facilities. At present, 20% of all passengers reach the airport by train, but this will hopefully rise to 40%. Together with the remaining expansions, this means that 4 times as many people as now will be using train services. So, to accommodate that sharp increase, the underground station will grow from 3 to 6 tracks. The overground NS facilities will be fully integrated into the airport's new enlarged station building. It might all sound quite simple, but still things have to carry on. After a very short preparation time of 3 months, the construction team started the job in April 1989. The constructors quickly made all the necessary calculations to determine the form and dimensions. Once the shape and dimensions are known, computer draftsmen create display screen diagrams with the aid of AutoCAD programs. The diagrams are then stored on floppy disks and are later printed out with the help of a plotter. Sometimes it's hard to believe that Schiphol is built in a polder and actually lies 4 meters below sea level. Tunnel building here is therefore no easy task. At 6.5 meters below surface level, a deep impermeable peat layer prevents the rising of salt groundwater. The tunnel excavation shaft is more than 10 meters deep, which means that the peat layer is penetrated, and theoretically the underlying salt water is able to rise and make the surface water brackish. Hence the reason that underwater concrete is used for construction work. Schematically speaking, the job may be broken down into 5 phases. The first phase, involving partial excavation of the existing tunnel surface, boring and the plunging of stakes upon which to anchor concrete support beams and insert sheet pile walls, haulage piles and pressure piles. Excavations are first made to a depth of 2 meters, so that purlins and props can be fixed, after which the props are stressed with the help of screw jacks. In order to counteract the effects of salt water, the excavation shaft is flooded with fresh water, whilst the so-called wet excavating continues. Digging carries on to just beneath the peat layer, at which point one hits on a stratum of compressed sand. The sand is sprayed loose and extracted until the right depth is reached. A 1 meter thick layer of underwater concrete is then cast around the exposed pillar heads. To ensure that the tunnel bed is absolutely watertight, concrete is then injected between the underwater concrete layer and the existing tunnel floor. At this stage, the excavation shaft can be pumped empty and the last tunnel building phase can begin. Anchoring pillars are fixed into the tunnel at floor level. The tunnel floor is then prepared. Once beams, columns and the tunnel sides and roof are ready, a water-resistant layer is poured between the tunnel and the sheet pile walls. Once the sand level has been topped up, the tunnel is in principle completed. These then were the plans. Now the real work has to begin. As the sheet piles will later be supported against the underwater concrete floor, a relatively short length of 12.5 meters may be stamped in. Once the sheet pile walls are in place, the so-called vibro combination piles may be plunged into the ground. For these purposes, a 23-meter long pipe is driven into the ground. When this pipe is in place, a concrete core is put in. The concrete piles that are to serve as haulage piles are given a core with a reinforced head of pre-stressed concrete. The occasional compression piles are given a smooth core. The space between core and pipe wall is filled with grout. This is a mixture of cement and water. When the pipe is vibrated out of the ground, the grout flows out mixing with the surrounding earth and creates perfect cohesion between the pile and the ground. Placing the pipe props looks like a gigantic task, but when done by professionals, it is simple. The 400-ton crane effortlessly raises the 35-meter-long 10-ton heavy pipes from the articulated lorry and puts them straight into position. By introducing an eccentric pre-stressed force of 1200 kN, one ensures that the existing tunnel and the sheet piling wall is not displaced. As soon as the pipe props are in place, fresh water is pumped in and kept at a given level. It regulates the saltwater balance. A dragline crane is used to excavate to just beneath the peat layer. A special sand suction machine is employed to loosen the solid sand mass and extract the excess. The extracted mixture of sand and water is conveyed via pipelines to a storage depot situated between the runways. The sand is later used for finishing work. Where areas cannot be reached with the sand extractor, For example, in the sheet piling cavities, the sand is removed with a kind of spear which blows it away under water jets of high pressure. If things are going to be really watertight, the underwater concrete layer must extend for 1.5 meters beneath the existing tunnel floor. Divers go down to extract the excess sand and gravel there. Working 10 meters beneath the surface for hour-long periods in cold and murky water is certainly no easy task. In order to sufficiently pour in the underwater concrete, rails intended for a bridge wagon are laid on the pipe props. The concrete is pumped directly from the lorry to the bridge wagon and is distributed with a so-called hopper float. The hopper float consists of a hollow tube with a propelling axle and a spreading element. It ensures that the concrete does not segregate. As soon as the underwater concrete is hardened, another watertight layer is ready and the pit is pumped dry. Since the reinforced pile heads are half buried in the underwater concrete, the haulage piles see to it that the sealing layer is not pushed upwards by water pressure beneath. Each excavation tunnel is roughly 100 meters long and is closed off with a dividing section composed of sheet piles propped up against the dividing floor. Now the real tunnel building can commence. To achieve a good connection between the existing and the new tunnel, reinforcement rods are bored in at floor level and are tightly secured. Work has to continue in all weathers. The rhythm may not be disrupted. With the use of two curved shuttering sections, it is possible to complete 20 meters of tunnel every 3 weeks. It requires accuracy and skill to assemble such shuttering. At present, whilst the first tunnel base is being laid, the weather is not very helpful, as it is raining continually. The great advantage of curved shuttering is that it is easy to transfer, section by section, with a simple winch system. Once entire concrete sections have been laid along considerable stretches, it is necessary to repair the sealing layer between tunnel and sheet pile walls. A mixture of powdered clay, cement, and water is poured into these cavities. Gravel is then added, and finally sand. Once the pipe props have been removed and the sheet piles pulled out, this tunnel section is in effect ready for use. If the entire rail tunnel extensions are completed by the turn of the century, NS will have brought off one of its major Rail 21 projects, and Schiphol will be able to boast of excellent rail connection facilities.